Okay, here's the engine that I was talking about earlier. 1911 Cadillac, 286 cubic inches in 4 cylinders. Cast iron cylinders themselves with the copper water jackets on the outside. This particular engine has 5 main bearings on the crankshaft. And it's a little bit different in that this engine actually has a set of custom billet connecting rods I had made. They run Onan air-cooled generator bearings for 25 horsepower twin engine. Okay, so it's air-cooled, splash lubrication. That's what the bearings are originally used in that application. And you can see this particular engine also has a set of custom eggy pistons in it. The original pistons were made of cast iron and were very, very heavy, as you can imagine, because they're about the size of a juice can. But these new pistons should reduce the reciprocating weight by quite a bit. As you can see down below, the connecting rod goes into a well that's full of oil. These particular, I'll point to it over here, down in here, those are the wells that the oil is splashed up into and end up feeding the main bearings. Each set of bearings has a feed like that. Let's see, look in here. See ARP bolts. I don't know whether you can really see in the back there, but the camshaft actually has roller lifters in it. So for everybody who thinks that roller lifters is new technology, no, they've been using that actually since the pre-teens. This engine being a 1911 also uses it. My 1905 Cadillac actually has roller lifter in it as well. So what's old is new again. So the purpose of this afternoon is what I'm going to do is that the engine itself has been totally assembled. And before I start putting everything on the outside of it, the manifolds and the magneto and the oil tank and all that type of thing, I wanted to actually run the engine for a little bit just to make sure that everything's okay, because this is an untried combo. And I didn't want to have everything all together, trying to fire the engine up and then have something go sideways. One other thing about this particular engine too is that the intake and exhaust valves are actually from a Minneapolis Moline tractor that I bought. They were the correct size, seats were correct, so I just touched the seats up on these a little bit. The valves I took, I had to shorten them by about a ½ inch, harden the tips, and then re-drill them for the cotter pins because they used an original keeper setup. The shaft that you see sticking out over here is where the distributor goes, and the oil or the water pump is driven off of here, which will hang on later. This particular shaft drives first. There's an oil tank goes there, which I'll show you later, and then off the back of the oil tank goes the magneto, and that's what mounts on that set of studs. So what I've got is I've got a 3 horsepower electric motor here turning at 3,460 RPM. That is attached. It's got a serpentine belt pulley on it, and I've got a 4-rib serpentine belt on there. I made this tensioner up out of a couple of bits and pieces from Princess Auto. We'll be using a rubber strap to tension it. And then we've got that running around the flywheel itself. Now that flywheel weighs about 75 pounds, so and has been balanced to the rods and the crankshaft, so we're going to find out how good the balance on that is. Now, some of you may say 3,460 RPM, that's spinning really quick, isn't it? Well, if you look at the size of the pulley that's on there versus the size of the flywheel, when you look at the ratio at full RPM of the electric motor, it should turn this engine at about 496 RPM, so just under idle speed. So it shouldn't be stressing it out too much. I hope it's really not stressing it out at all, as a matter of fact. But I guess we're going to find out, and we'll just see how this thing is going to go.